All right, so kind of for our final part here, this is kind of, in my opinion, the coolest part. This is the most fun. Here's this, I guess, system me and Sean kind of developed for the Tetwin City power consumption. Uh, so the purpose of this was to allow the user to provide their own inputs to find power consumption, or even add a whole new add an observation, and then have it work with the data that's in the CSV file. So I guess the main we're basically using loops. We'll get to it here in a second. But here we're loading the data set. It's similar to everything we've been doing in the past, and here we're doing the train models. Again, using our inputs. Um, it's similar to what we did previously. Same thing, linear regression. And then so we want the first thing was to allow the user to predict power consumption. And so here we're just we're putting our print values. So we want to enter the temperature, our three inputs again: temperature, humidity, wind speed. And then these are our kind of our what's it called? Um, I can't think of the word, but miles per second percentage, and we're going in Celsius. Um, and then this is our one for our observation. Um, Again, it's using our inputs from our three main things um, for each of our three zones. So that's what this is our three zones right here. Here's our inputs. Um, and again, we're using observation module. And then this is what we want. This is kind of, I guess, what works it. Here's our main loop, which just kind of tells the user what to do and all that. Um, yeah, I'll have two at observation. Anyways, let's get to the fun part. Let's see how it works. So if you run it, let's say, okay, why is it doing that? Nice. Alright, I'm sorry about that. I had to restart my computer. I don't know why I wasn't processing the code. Anyways, the fun part, once you run it, okay, sorry. Okay, so once you run it, it's gonna ask us to enter our value. So for if you, let's say we want to find power consumption, you click one, enter the temperature Celsius. Let's say it's 43. Just to kind of show how this works, this is our humidity percentage. Let's say 15% humidity, and then our wind speeds. Let's just say it's not too windy. Let's say it's 10 miles per hour or meters per second, and then boom, it's got our loops here that me and Sean collaborated on. Um, Basically gives us our input. I mean our outputs, and it does all math for us. Here we go. It's in kilowatts for power consumption for each of our three zones. So it's pretty cool. But yeah, that pretty much sums up our my part of the project. A big issue I had mainly was just kind of creating the interface, especially when trying to create a new observation or add one to our data. There's a lot of problems that kind of came out of that. But we prevailed. We kept going. We still have a pretty good looking one. We got a good data. But now I'm gonna hand it on over to Sean, who helped assist in all this, especially when debugging. He helped a lot with the data sets for the wind zones, and we worked on this interface together. And yeah, I'm gonna hand it over to him, and then.
Hey, so I'm Sean Marchelli, and I'm going to be finishing up our video today. And I'm just going to start by saying kind of what we're going to go over. I'm going to do the pair plots, as well as discussing all of the issues that we have had throughout this project, kind of things that didn't really work, and as well just kind of like who did what, so you know everything. So to start off with, we have our pair plots. And this is based off of not only the data from the table, but also some of our own training and test sets that I created. As for the actual database description itself, so we can see the temperature likes to stay cold, and the humidity can kind of range all over the place in this Tetwin city. But overall, only 68 humidity. It's a lot better than Houston. The wind speed has been pretty low in this area, so we're not really seeing that affect consumption that much, not in most of the zones at least. The main factors are going to be our temperature and humidity, because that's what's changing more. They also kind of match up in their ebb and flow of highs and lows. And that is reflected as well in these pair plots. The wind speed is pretty much the same every time, no matter the city, no matter what it's doing. It just loves this whole pattern of going 0 and 5, and then a bunch of stuff in the middle. So as for data creation and linear regression, we kind of just have to forget about those. We're really looking for these temperature and humidity tables that are changing as well. Then the root mean squared was kind of off, but still in that range that we wanted, so that was great. As for a lot of the problems I went through, I'm sure you saw here that our formatting, for whatever reason, was not wanting to cooperate with us with how we were trying to input our data tables, specifically the time. Why that is, it took us a long time to figure out, and we still kind of don't know. So that isn't something that we've had trouble with for this project for sure, but thankfully it hasn't impeded the progress of creating all of our data tables and such. As well, down at the heat map, it's the same thing again. The formatting, it just doesn't like how we want to use our data, specifically the time, and this has been a really consistent problem. But once again, it has not stopped us from doing all this work that we've done, especially with the interface, which allows you to make your own observations and find power consumptions based on the models that we created and all the other deliverables that the assignment asked for. So that's good. As for who did what, I was mainly working on the literature analysis and the data analysis, and the creation of all these pair plots, so we can kind of decide what we wanted to use to create our own models and training sets, so that we can get pretty close to these linear regression root mean squareds from random samples as well as from the model itself. And then Hector, he was working on a lot of the heat mapping as well as the interface itself and all these other models that he made to predict the consumption based off of the analysis that I made. And then down here we have a little example of the interface and how it will work. And overall, this is just his work, the interface, the heat map, the predictive models based off of what I did, which is the actual data analysis and the pair plots, deciding what we wanted to use for our project. So yeah, that's it for me, and thank you so much.